So today we're going to be solving problem 9 from the 2018 AMC 10B. So this problem is going to be based on some probabilities, so some combinatorics. And yeah, let's do this problem then. So the faces of each of 7 standard dice are labeled with the integers from 1 to 6. Okay, and P is the probability that when all 7 dice are rolled, the sum of the numbers on the top faces is 10. And now we have to find the sum that occurs with the same probability as P. So the same probability as getting a sum of 10. So normally for combinatorics questions, the problem says that we have to find the probability, but here we have to find the case where we have to find the case which has the certain probability. So it's a pretty strange but cool problem we have here. So let's just list out all the possible sums we can get in ascending order. So the smallest possible sum we can get is when we have all the top faces of all 7 standard dice to be all 1, since 1 is the smallest possible number on each die. And so that will make the smallest possible sum be 1 times 7 equals 7. So the smallest possible sum is 7. And then and the second smallest possible sum would be, well, we can just add 1 1 to this. Like we can just so this sum will be given by 7 1s, and then we can just add a value of 1 to one of them. So the second smallest possible sum would be 7 plus 1, 8. And similarly, the third smallest possible sum, is 9, because we can just add 1. We can just add 1 1 to this. So if we just list it out, so we have this, and this is going to go all the way up to the largest possible sum, which is, so we're going to get the largest possible sum when all the top faces are 6s. So that will give us a sum of 6 times 7 equals 42. So we can clearly see here that if we list out all the possible sums in ascending order, then we're going to get an arithmetic sequence from 7 to 42 with a common difference of 1. So that's pretty neat here. So what we're going to do here now is we're going to look at, so we've got all the possible sums here. Now we're going to look at their probabilities so that we can find a sum that has the same probability as P and as 10. So let's change our colors here to kind of distinguish this. So we're going to look at, so the smallest possible sum is 7. And then the largest possible sum is 42. So we're going to look at the probability. That's a big P, so don't kind of confuse this with this big P and small p. So this is a variable, and this is the probability function. So the probability of getting a sum of 7, this denotes the probability of getting a sum of 7, and this will denote the probability of getting a sum of 42. So as I said before, to get a probability of 7 and to get a sum of 7, we have to have all the top faces, all 7 top faces, to be equal to 1s. So the top faces will look something like this. So it's going to be 7 1s. And then for this, we're going to have, actually I'm going to put plus signs there so that we can remind ourselves that this is the sum. So 1 plus 1 plus 1 plus 1 plus 1 plus 1. That's 6 1s. Yes, okay. And to get a sum of 42, all the top faces have to be 6. So this will be basically, to get a sum of 42, the top faces will all be 6. Will all be 6s. So it'll look like this. 2 more 6s. Okay, that looks right. So we got that. And we can see here that the probability of getting a sum of 7 is to have all of the top faces to be equal to 1. So the probability of getting that case where all the top faces are 1s is 1 over 6 times 1 over 6 times 1 over 6 times it 7 times. So it's going to be 1 over 6 to the 7 for this. And that will be equal to this probability too, because we have to get all 7 top faces to be 6s. So it will be 1 over 6 times 1 over 6 times multiplied 7 times. So that'll be the probability here is also going to be 1 over 6 to the 7. So here we find that the probability of getting a sum of 7 is equal to the probability of getting a sum of 42. So there you go. We kind of found a relationship here. So now that we found the relationship between the smallest possible sum and the largest possible sum, we're going to now look at the relationship between the second smallest possible sum and the second largest possible sum. So let's now put that in another color. The probability of getting the smallest possible sum, which is, as we found here, 8. And the probability of getting the second largest possible sum is, so the second largest possible sum would be, we can just minus 1 from that. So like the second largest possible sum will be an assortment like this, but then one of the values will be 1 less. So basically, so the second largest possible sum will be 42 minus 1, which is 41. So we have to find a relationship. We have to find a relationship between the probability of getting a sum of 8 and 41. So here we can just go ahead and just count. Like I guess it's not too hard, but there's a more strategic way to do this. So if we look here, okay, so the probability of getting, okay, never mind. So we can see that the number of ways to add a 1. So to get from a sum of 7 to a sum of 8, we have to add, oh no, let's put that in, actually, yeah, let's put that in pink. So to get from a sum of 7 to a sum of 8, we have to add a 1. And to get from a sum of 42 to a sum of 41, we have to take away a 1. So we see here that, so we know that by counting stuff, we know that the number of ways to add a 1 is the same as the number of ways to take away a 1 from something. So the number of ways to add a 1 and the number of ways to take away a 1 is the same. And we know that the probability of getting a sum of 7 and the probability of getting a sum of 42 is the same. So, okay, I'll just summarize that again. So, the probability of getting a sum of 7 is equal to the probability of getting a sum of 42. And the number of ways to add a 1 to this is equal to the number of ways of taking away a 1 from this. So, this tells us that the probability of getting a sum of 8 is equal to the probability of getting a sum of 41. So that was some mind-blowing stuff there. I hope you guys got this. So instead of just looking at this individually, instead of looking at these probabilities individually, we looked at the previous case. We used the previous case to we looked at the relationship between the previous case and this case to easily find a relationship here. So that was neat. And now let's look at, so we're kind of getting an idea here of a pattern between this. But we're going to have another example to, get this a bit clearer. So we're going to put this color now in blue. So probability of getting So now we're going to look at the probability of getting the third smallest possible sum and the probability of getting getting the third largest possible sum. So the third smallest possible sum is, as we see here, 9. And the probability of getting the third largest possible sum, which is, just take away 1 from this. Just take away 1 from this, which is 40. There we go. And then, now we have to find a relationship between these two. There's going to be a similar idea to this. So if we look here, to get from a sum of 7 to a sum of 9, we have to add, okay, let's get this neat. Oh, there we go. We have to add 2 ones. So we have to add 2 ones. So we can either add, we can add 2, or we can just add a 1 and then another 1. But yeah, so there's a couple of number ways to add 2 ones to this sum. And then here, this is going to be difficult. Actually, I can just draw it here. And then here we have to subtract 2 ones from this sum to get. We have to subtract 2 ones from this sum to get a sum of 40. So if we look here, we can see that so firstly, the probability of getting a sum of 7 is equal to the probability of getting a sum of 42. And we also know that the number of ways to take away 2 ones is equal to the number of ways to take away, I'll say that again. So the probability of getting a sum of 7 is equal to the probability of getting a sum of 42. And the number of ways to add 2 ones to something is equal to the number of ways to take away 2 ones from something. So that, and then we know that we have to add 2 ones to this to get this, and to get from this sum to this sum. And we have to take away 2 ones from this sum to get this sum. So this concludes that the probability of getting a sum of 9 is equal to the probability of getting a sum of 40. So here we get that the probability of getting the third smallest possible sum is equal to the probability of getting the third largest possible sum. So coolio. So we found a pattern here. The smallest possible sum. The probability of getting the smallest possible sum is equal to the probability of getting the largest possible sum. The probability of getting the second smallest possible sum is equal to the probability of getting the second largest possible sum. The probability of getting the third smallest possible sum is equal to the probability of getting the third largest possible sum. So I'll just mark that there. So first smallest possible sum and first largest possible sum, whatever that means, and second smallest possible sum, second largest possible sum, and third smallest possible sum and third largest possible sum. Okay, that makes it a bit easier to see. So what we see here is, so we see a pattern, but why is this true though? So here we can see that this is because the number of ways to add, a number, so we know that okay, I'll say that again. So this is because the number of ways to add a certain number of ones to an assortment of 7 ones, which is the smallest possible sum, is equal to the number of ways to take away a certain number of ones from an assortment of 6s, from an assortment of 7 6s, which is the largest possible sum. So which means that the nth smallest possible sum has the same probability as the nth largest possible sum. So now we can find a relationship for the sum of 10 now. So the probability of getting a sum of 10 and the probability of getting, so 10 is the fourth smallest possible sum here. So the fourth largest possible sum would be 40 minus 1, 39. And that's the fourth largest possible sum. And from what we discussed, synthesizing the information, we found, and like the patterns we found before, and patterns we found previously, we can conclude that P of 10 is equal to P of 39. So therefore, 39 has the same probability as the sum of 10. So we can find that the answer to this question would be 39. I'll just put that in black. 39. And there's our answer there, D. So instead of brute forcing this problem by looking at all the possible sums we can obtain and then looking for that one sum that has the same probability as the occurrence of the sum of 10, we easily solve this quickly by finding a pattern between a pair of sums. So we found that the nth smallest possible sum is equal to, has the same probability as the nth largest possible sum. So we use this to easily find the sum that has the same probability as the sum of 10. So yeah, that was a pretty elegant problem there. So hope you guys enjoyed this video, and see ya in the next videos.